Hello my friends from all over the world, talking to Rafael, your teacher from Brazil. Welcome to my channel. On this video, I'd like to speak with you guys about pressure and about the influence that fluids make on the pressure that we feel, okay? My friends, let's take a look at this example that I drew on the board. I attempted to draw here a U-tube and I put here three fluids. The first one is oil, the second one is mercury, and the third one is water, my friends. And what we wish to calculate is the value of this distance here, because we know that water has a higher density than oil, okay? If you put oil in water, the oil is going to float. But here at the bottom we put mercury, and mercury has a much higher density than water and oil, okay? So mercury here at the bottom, and I put oil here, water there, and what we wish to calculate is the value of this distance here, this value of x, my friend. The exercise told us that the density of water is 1 grams per cubic centimeter. The density of oil is 0.8 grams per cubic centimeter, and the density of mercury is 13.6 grams per cubic centimeter. Here in Brazil we use commas. Here I know that in the United States people use points here, but let's pretend that this comma here is a point, because in this way we are going to please everybody in the entire world, alright? So my friends, how can we calculate this distance here? It's very easy. Pay attention on that. First of all, what we need to do is to understand the idea of pressure. What is pressure? Pressure is force over an area. However, we are interested in the weight of the fluid here, and this force is going to become the weight of the fluid over an area, okay? But the weight of a fluid can be represented by its density and its volume, okay? It is going to be the density, the volume, alright, and the gravitational force, it all divided by the area, because density times volume is the mass, and mass times gravity is weight. Okay, but volume here can be represented by the height times the area of the cross-sectional area here, okay? So we can substitute this by density, height, area, and G divided by area. And if we cut area with area, we're left with the expression that we are going to use, which is density, height, and gravitational constant, okay? The acceleration of gravity. So we are going to use this, okay? Let's put it here because we wish to remember it. The pressure is going to be this, and this, and we are going to use this expression here to calculate what we wish. Alright, my friends, let's go ahead and continue doing what we wish to do. And what we wish to do is to calculate this distance here. So what we need to do to calculate this is to choose a point of reference. And what is going to be the point of reference for us? The point of reference for us here is going to be the point A in this leg of the U-tube and B on this leg of the U-tube. If they are in the same horizontal, in the same level, we can guarantee that the pressure on A is equal to the pressure of B, okay? So we can guarantee that the pressure in A is equal to the pressure in B, okay? But what is the pressure in A? The pressure in A is equal to the atmospheric pressure, okay? The atmospheric pressure here. So the pressure in A is equal to the atmospheric pressure plus the pressure caused by the weight of this column of fluid here, which is going to be the density of water, okay, H2O, the density of water plus this height here, H2, times this height times the constant of gravity, the acceleration of Earth's gravity. Okay, this is the pressure at point A. Now we wish to calculate the pressure at point B. The pressure at point B is going to be the atmospheric pressure at this side here. So here at this side, the atmospheric pressure, again, the pressure of the weight of this column of oil, which is going to be Rho oil times the height H1 times the constant of gravity, okay? And here, continuing in this side, we have this column here, and this fragment of the column is made up of mercury. So it is going to be the density of mercury times this height here, I called it H3, and the acceleration of Earth's gravity. All right, my friends. Can we do that? Yes, of course we can do that. We can do that, and we are doing that. Here we can immediately see that we can cancel this with this, because if I pass this to this side, it becomes 1. All right, then what is the next step that we can make here? The next step that we can make is to we can put gravity here, we can cancel here gravity with gravity here, and we are only left with these things here, H2O times H2, which is equal to Rho oil times H1 plus Rho Hg times H3. All right, my friends. We can continue doing that in this fashion here, my friends. Let's pay attention, and here let's compute this. I'm going to use my calculator here because we have to multiply, and my calculator says that it is going to be like this. Let's continue, okay? Let's not stop. Let's continue doing what we wish to do, okay, my friends? Let's continue do. This density here is 1 gram per cubic centimeters. This height here, H2, is 32 centimeters. Okay, it's gonna be equal to the density of oil is gonna be 0. I'm gonna use the comma, but pay attention. You can use a point there, okay? Grams per cubic centimeter plus the height of this thing here, which is going to be, okay, so H1 here, H1 was given, and it is 6 centimeters plus 13.6 G. Okay, very good. We are almost finishing, and we can multiply this by the height 3. Alright, friends, let's see what we get from this. What we can get from this is this, that my, okay, this is simply 32 here, cubed here, 32 this side grams per centimeter squared. Here I have 4.8 grams centimeter squared, and this I have 13.6 grams per centimeter cubed, H3. Okay, if I pass this to this side, my exercise here tells me that I'm gonna find this 27.2 grams per centimeter squared. which is going to be equal to 13.6 grams per centimeter cubed times H3, and I'm going to pass this number here dividing to get H3, okay? So we are going to know that H3 is going to be equal to 2 centimeters. 2 centimeters. For us, H3 is 2 centimeters here. This is going to be 2 centimeters here, and H1 here is 6 centimeters, okay? So we can complete this exercise by simply doing this. We're going to do just now. We know that H2 is going to be equal to x plus H1 plus H3. We already know that H2 is equal to 32 centimeters, okay? X plus H1 is 6, and here we calculated that it is 2. We put this and this to this side, and we find that x is equal to 24 centimeters. Okay, my friends, I hope you guys enjoyed the video. My friends, thank you for watching. Goodbye.